Hi everybody. Today I am going to present about the topic audio and microphone in multimedia. In that we will go to discuss about what is a sound, what are the characteristics of sound and digital audio system, MIDI, and finally about the microphone. What is a sound? Sound is simply waves of compressed air that comes out from its source. However, human ears are sensitive to these compressed waves. As the sound waves interact with our eardrum, the signal is sent to our brain where it will be converted into sound that we can recognize. Two types of sounds available: analog sound, digital sound. Characteristics of sound and digital audio. Sound is based on two characteristics. One is energy and another one is transport medium. For example, energy from a drum is converted into pressure that is transmitted by the air, which is called as a transport medium. Sound waves has two characteristics. One is amplitude and another one is frequency. Amplitude is the power of the sound, also known as the intensity of the sound. The louder the sound, the larger the amplitude. Frequency is the rate at which the sound is measured. It is usually measured in hertz. This is the example for the different devices produce different sound having varying frequencies and varying wavelength. There are three classes of sounds: voices, music and sound effects. Voices is defined as talking by human. It does not have a pitch and tone. Music is defined as singing by human. It have rapid changes in tone and pitch. Sound effects can be voice or music. It is vary in tone, pitch and time. Digital audio system. Digital audios are created when the characteristics of the sound wave is represented using number that is in the form of binary zeros and ones. This process is known as digitizing. We can digitize any sound produced by the different devices such as microphone, synthesizer, etc. Digitized sound is a sampled sound. The quality of digital recording depends on how often the samples are taken. Higher the sampling rate, better is the quality of sound. This is an example for the sound signal produced by a microphone is converted into an analog digital signal, which is again converted into an analog signal. The normal sampling rates used in multimedia are 44.1 kHz, 22.05 kHz and 31.025 kHz. Larger the sample size, the recorded sound will be more accurate. The value of each sample is rounded off to the nearest integer called quantization. Digital audio software support playback, record, stop, fast forward, reverse, rewind. To edit digital audio, it offers the following features: trimming the clip and splicing and assembly, volume adjustment and format conversion, resampling or downsampling and fading and fade out, equalization and time stretching, digital signal processing and reversing sounds. MIDI, Musical Instrument Digital Interface. It is a communication standard developed in the 1980 for electronic instruments and computers. It allows instruments from different machines to communicate, but MIDI data is now digitized. It is only music data stored in numeric form. It is device independent. The process of creating MIDI is quite different from digitizing a recorded audio. Digitized audio stores audio information in the form of bitmap images. The MIDI stores musical information in the form of vector graphics. For digitized audio, we need to play the recording through a computer device that can digitally record the sound. To make MIDI, we need notation software, sequence software, synthesizer, MIDI keyboard. These are the following advantages of MIDI over digital audio. MIDI files are more compact. It can easily embedded into the web pages. Its sound source is high quality. It is completely editable. They can be easily converted to musical notations and vice versa. Next we will go to see about the microphone. Microphone is a type of acoustic transducer or sensor. A microphone is an acoustic to an electrical transducer which converts the sound energy into an electrical energy. Early microphones were invented for communication purposes. In 1665, Robert Hooke was the first one to experiment with a medium other than air. The first microphone, called a carbon microphone, was introduced in 1876 by David Edward Hurst, Emil Berliner, and Thomas Edison in the US. The three main types of microphones are used. They are dynamic microphone, condenser microphone, ribbon microphone. Diaphragm is the most important part of microphone, which receives the vibration from the sound waves. The electrical circuit is used to change these detected vibrations into an electrical signal. Thickness and material of the diaphragm are changed depending on the sound waves you wish to pick up. Microphone pickup patterns. Pickup patterns helps to reduce unwanted signals from getting pickups. There are three popular patterns are available: omnidirectional, bidirectional, and monodirectional. Omnidirectional microphones. Here, these microphones are used to collect sound from all around 360 degrees. These microphones can be shared by the group. Bidirectional microphones. These microphones are used to collect sound from the two directions. A true bidirectional microphone can be a pressure gradient or velocity transducer, meaning its response to the sound will depend on the direction sound wave is coming from. The diaphragm is completely open on both sides so that it can react to pressure changes on either side of the diaphragm. It is sensitive only to sound surrounding from directly in front or directly behind. Unidirectional microphones. It is used to record sound in one direction. It collects most of the sound from the front and very little from the back and sides. So this type of microphones is annulled at 180 degrees. It will not respond to sound approaching directly from the ear. So this results in a heart-shaped pattern. So it is also called as cardioid microphones. These are the types of microphone. Handheld microphones normally we use. Type-in microphone, surface mount microphone, shotgun microphone, wireless microphone system. The applications of microphone are telephones, hearing aids, public address systems for concert halls and public events, motion picture production, live and recorded audio engineering, two-way radios, megaphones, radio and television broadcasting, and computers for recording voice, speech recognition, etc.